Hi, my name is Phil Bagg and we're going to explore infinite loops in this video. I firmly believe that the more teachers understand what they are teaching, the better their lessons will be and the greater their pupils' programming success. You're looking at a semantic wave, which is great for thinking about curriculum sequencing. The idea is to take a complex idea such as an infinite loop and unpack the concepts until we get to the most concrete examples and simplest meanings. Starting at the red arrow, you can see us doing that on the downward curve from left to right, relating to everyday examples such as days of the week. At the bottom we have the most concrete everyday examples of an infinite loop in an algorithm, such as the "are we there yet" loop. Then the curve to the right is when we repack meaning, so we can get back to the larger meaning. Flow of control in an infinite loop, how an infinite loop ends, difference between count controlled and infinite loop. In the rest of the video we're going to unpack these even more. Infinite loops are just one type of loop. If pupils have already studied a count controlled loop, it will be worth reminding them of that pre-existing knowledge at this point. Helping pupils to link pre-existing knowledge of loops to our new knowledge of loops is important. Pupils will then find it easier to add this knowledge into their schema of understanding. This is harder with infinite loops as they are harder to find naturally. The days of the week are one good example of an infinite loop. Our heart beating is part of an infinite loop. True, it will end at some point when we die, but it seems like an infinite loop to us. The moon orbiting the earth is part of an infinite loop, as is the earth orbiting the sun. True, like our heartbeat, it is not truly infinite, but near enough to infinite to help us here. Actions inside the loop need to be identified in an algorithm. One method is indenting what is inside a loop. Acting out an everyday algorithm enables learning to be less passive and provides instant teacher feedback on who understands it so far and who does not. We can also point out that everyone carried out this algorithm at different speeds, which gives us a chance to ask pupils how we might make it more precise, which is a feature of a good algorithm. Identifying that nothing stops the loop is important. We can make the point that a human will get bored and stop, or will eventually run out of energy and stop. However, a machine will continue to carry out an infinite loop unless it is shut down or the program is stopped. Identifying the flow of control using simple notation like this helps pupils to build up a mental image of how the loop works. Here the dots represent the actions, the line represents the order the actions occur. These can be provided like it is here or drawn live over an algorithm or code. Use an example that has actions before the infinite loop introduces the idea that we can have instructions before our loop. This is likely to be the case in many code and algorithmic examples. It helps to identify what is inside the loop from what is outside the loop. Algorithms can be written in any way another human can understand, so other methods other than indentation can be used, but indentation works well as many programming languages indent code inside loops, including, if you look carefully, Scratch. Asking pupils to draw the flow of control makes them think about the order the actions are carried out in. This is helping them build up an idea of what will happen when they use this in programming, which is part of developing a notional machine, how a concept will work inside a computer. When pupils write their own infinite loop in algorithm form, it gives us a chance to check if they understand the concept in one of its simplest forms, and is helping them develop a planning method. Teachers can look out for pupils who included actions after the loop and help them correct their algorithm. An infinite loop is a member of the indefinite loop family. It is great to introduce a universal term that you can come back to in later lessons. Indefinite means we do not know how many times it will loop or how long it will run for. I wonder if you noticed that I did not use forever in any of my everyday algorithms. I use loop always. I try and avoid forever as it is language that Scratch uses for an infinite loop. There is research that suggests that making a clear distinction between the algorithm level and the code level makes it easier for pupils to transfer the concept between algorithm and the many programming languages they will meet. Because pupils have learned about a concept away from code, their knowledge of the concept is not tied to the specific code language used. Here is Scratch code. We can see that Scratch uses forever for its infinite loop. We cannot write a scratch infinite loop in any other way. When we are writing an algorithm for other people to understand, we can use a wide range of language and symbols, which could include loop always or always loop. Using tools such as the snipping tool or snip and sketch, we can cut code out and easily draw the flow of control on top of it. This might help us to see where a bug is in our code or help us understand why it acts as it does. If we have already used a count control loop, a really important step is to compare and contrast loops. Both repeat things, but one will end and the other will not. One is a definite loop because we know exactly how many times it will repeat. The other is indefinite because we don't know how long it will repeat for. One can have actions after it, the other can't. Knowing these will enable quality programming choices. Let us sum up our knowledge about infinite loops. An indefinite infinite loop is indefinite because we do not know how many times it will repeat or when it will end. It's called a forever loop in Scratch programming. Has a flow of control, order the commands are executed in. Can be used in an algorithm or in programming. My thanks to the Everyday Computing team who have published a great repetition trajectory that I've definitely learnt from. Do go and look at their research. My thanks also to the others mentioned here for their research and support. As always, all misconceptions and errors are my own. Do get in touch if you have any questions. In Hires, Hampshire inspectors provide resources on every area of the curriculum that you can find in our Moodle. You're welcome to subscribe if you're in or outside of Hampshire. Thanks for listening.